What's up, hackers? Welcome to Chill Code. My name is Taggart, and tonight we are starting a greenfield project, kind of. Luffy, thank you so much for the follow right off the bat. So let me tell you a little bit about what we're doing, why we're doing it, and kind of the background of all of this. So if you're new to the channel, one of the projects that we've put a lot of time in to on Chill Code is Offensive Notion. Offensive Notion is the command and control implant written in Rust and using the Notion note-taking app as its substrate, I think is the word that I want there. Essentially, what Offensive Notion does, if you don't know, is it implants into a target system, and rather than setting up a whole Teamserver infrastructure, what it does is it uses the Notion API to send and receive data to a Notion page. And all of the data that you're receiving from your target is displayed there. And it is also where you can input commands, right? So you can just be on a Notion page and enter commands with a specific syntax that we came up with that allows you to interact with the agent. And Husky Hacks and I put this together, and we've been working on it for, God, it feels like a long time, but it's actually really been since January. So most of the year, I suppose. And as we're closing out Offensive Notion's first year, we have some big plans. Things that we want to do to grow the project and kind of move beyond maybe just being Offensive Notion, in all truth. What I mean is, we've put together, as it turns out, kind of a cool command and control framework. It doesn't have every capability that Sliver or Cobalt Strike or even Spider's Havoc does in terms of pivoting or views. It doesn't, but it does have a lot of cool tricks up its sleeve, and it has a structure and this idea of living off trusted sites that makes it really interesting to play with. Hey, Born to Lose, Built to Win. I'm going to recommend that you join our Discord because there is a career section there. And then folks can ask you a little bit more about your experience and put you in the right place. But yeah, so as Offensive Notion grows, we realized we put together something that was cooler than Notion, basically. And rather than kind of tie the functionalities to a single app, we want to think about how do we abstract that out and how do we kind of build off of that. So there's a lot of work to do involved in that. But one of the first things to do is refactor some of that code so that it's not as Notion dependent, meaning that we would modularize all of the Notion components, right? And so modularize the Notion components and then build kind of a more general interface for what we're calling channels. And those channels would be the trusted sites that you're going to live off of, and that would be your intermediary, whether it be Notion, whether it's GitHub, right, or Twitter, or whatever your kind of trusted site is that you're sending data to as your command and control interface. We would create different implementations for those different trusted sites and then allow the operator to choose which one they configure for their target. So you could have one that's using Notion, you could have one that's using Twitter, whatever it is, and then you could have a single server that is collecting that information. So that's the other part. And this is the part that we kind of left off in the first place. One of the cool things about Offensive Notion is that we didn't have to write a team server because Notion was the team server. But there are some limitations there, and one of the big limitations that we were thinking about was operational security. So, and this was actually something that Al Hazred brought up over the winter, was, you know, if you're in an environment that has HTTP proxying or TLS decryption of any kind, then the information that Offensive Notion is sending is readable, right? The commands are readable. And so how do you solve that problem? You solve it with encryption. So imagine a situation in which you have an agent that is essentially encrypting messages to a recipient with that recipient's public keys. We do asymmetric key encryption, right? So the agent has the public key, and the fact that the defenders have it also doesn't matter, because we would have the private key only. So the agent has the public key, it encrypts the message with the public key, then it sends the data up to Notion or wherever. And then, rather than look directly at that Notion page, you, as the operator, use a Teamserver. Really, it's a client. In that case, it's like an interface client that receives that encrypted data, and with a private key, decrypts that information, so that the only place that the information is decrypted is on an operator-controlled machine, not even in the cloud, right? That the information would still be encrypted on those trusted sites. So that's a little bit more OPSEC safe, and that goes right in hand with the responsible red teaming that Husky's going to be doing a course on soon. Hey, Turco, good to see you. So where I wanted to focus tonight was thinking a little bit about the Teamserver. Let me change up the tunes just a little bit. It's a little high tempo for working on code. There we go. That's better. Is Husky's course going to be on the Taggart Institute? It sure is. Husky's Responsible Red Teaming course, coming soon, is going to be on the Taggart Institute at learn.taggart-tech.com for free. I've seen the outline. It looks incredible. It's not a course for beginners, but I think it's still a really important course that covers the ethics and the responsible operations for offensive security work. I think it's really cool. So with all of that in mind, I've kind of started a greenfield project, which is not Offensive Notion, but it is Trusty Team. And essentially, this is going to be the Teamserver client aspect of this. So what Trusty Team will do, well, let's kind of diagram it out. Let's get into code here, and I'll just create a new text file, and we'll just kind of explain what we're doing. So the basic idea is, you know, let's say we have our target here. You know what? This is going to be more annoying in VS Code, actually, than it's going to be in Vim. So we're going to do it in Vim. So let's say that we have a target. Now the target has been compromised, right, with an Offensive Notion or other kind of living off trusted site agent. Well, that thing is going to phone home to whatever the trusted site happens to be. So let's say it's Notion, let's say it, whatever it is, but it's the trusted site. Living off trusted site is sort of the term for this. And there is a huge list of them at Lots Project. I think that's right. Yeah, lotsproject.org.com. And in fact, if you look up Notion, we're on here. In fact, we're on here because of Offensive Notion. But yeah. Thank you, Mr. Docs, for managing this thing. So all of these are options, right? To one degree or another. Pastebin is a fun one. Anything that has an API, essentially, is an option here. So, okay. Nope, wrong thing. There we go. So, the idea is, if this data is encrypted, then I can't just look at that page, whether it's a Notion page or whatever it is, in order to read it. What I want to do is have an admin client, and that thing would read down the lots data, and then it would decrypt the data with the private key. It would send data back to the LOTS site, basically. ASCII diagramming, you gotta love it. Send data back to the LOTS site, at which point the data goes back to the target. Right? Because the target is polling for information from the trusted site. So what we're thinking about adding is this whole situation right here. That's the basic idea. Welcome, Cheeseburger Merv. Now, we have a lot of options and ways in which we could do this. I would like to do it, first of all, in Rust, and I would like to do it rather than developing a Cobalt Strike or Havoc-like user interface, because I don't want to do that, and I definitely don't want to write an Electron app or anything like that. So instead, we're going to go for a terminal user interface. Yeah, hey, Cheeseburger, you might want to figure out real quick what kind of place this is. This is a place that prioritizes learning and on-topic conversation. So, to get that started, I want to also reason a little bit about how to build this in a way that isn't Notion specific, right? How do we describe these channels and the way that they are, and the way that we interact with them? Thank you, Sar. I like Rust for this, in part because it allows us to reason about these kinds of things directly within its type system. By defining types and structs and enums inside of Rust, it really helps us understand what kind of the ways in which we could interact with these things. So if we describe a channel, what do all channels have in common, right? And a channel is a trusted site through which we are going to interact both with the target and the operator client. It needs to have, broadly, it needs to have a send and receive, right? Or a TX and RX capability, right? We need to be able to have some sort of auth config, right? Whether it's an API key or some sort of token, whatever it is that allows us to authenticate to that thing. And we also have to understand that that auth is broadly going to be available to defenders if we're not careful. Now, we do try, actually, in the offensive Notion agent to encrypt this stuff as much as we can, but if there's a memory snapshot, it's just there. So channels have a transmit, they have a receive, they're going to have some sort of configuration, whatever it is. In the case of Notion, there's also like the parent page, but the idea is that all of that is configured within what we will describe as a channel config, right? And then different channel configs can have different components. And then they need to have some sort of update capability, right? So that we can change configs on the fly. If we need to change, for example, what GitHub issue or something we're using as our intermediary, or changing which Notion parent page, right? We need to have a way to update them. And that's kind of it. The only other thing that we need to do is make sure that they can provide commands. Meaning that inside of Offensive Notion, we have this idea of a command, whatever that command is, whether it's a cd, ls, get system, whatever it is. So the output, essentially, of the receiving of data has to be commands. And then the sending has to be encrypted results. That's basically it. So that's kind of our channel idea. And then if we think about the client, hey, Leon, what does the client have to do? The client has to have a private key. So it has to have a config of some sort, right? And the config is going to be basically like private key and then channel configs. Any channel configs that we are interested in, that's going to have to be there. And then it's going to have to pull for data. And the way that I'm imagining this, right, it can pull across multiple channels, not just one, right? Because if I just have a single kind of channel or a single target, that's no good. I need to be able to interact with multiple targets at once. So my client has to be able to do that and then select and interact with multiple targets, right? Display statuses. And then, of course, you know, send data in an encrypted format. And what I'm kind of imagining is that a new public key is generated when the agent is initialized, right? Or a new key pair is generated for sending data. For receiving commands, it'll have to be here. You see what I'm saying? So that it's encrypted both ways. So our client is going to have the agent's public key. And yeah, the private key is going to be here. So it's going to be like half invisible to a savvy defender. But there's still, but regardless, this part will be encrypted, which I think is important. Okay. I think that's basically it for the client. And then the trick is, what is the design of this going to look like? And you might notice that I'm doing a lot of planning before I write any code. This is the benefit of experience, where writing things down and a little bit of prior preparation prevents poor performance. And a lot of this is, what's the term? Storyboarding, right? Where we're doing some planning for what the user experience of this is going to be. And yes, it is a user experience, even for an offensive tool. All right, so we'll save this out. Notes.txt. All right, so that's kind of the first thing that we have in Trusty Team. And yeah, I'm going to add the notes.txt. It's a private repo. I'm not too worried about it. I'm more of a solve it as it comes type of guy. Winky emoji, lol. Do better. Sorry, like, do better. There's that will bite you. I promise that learning to prepare and plan, plan the code than code the plan, if you want to put it that way, is going to be a much more beneficial way if you're interested in doing deep software development. Definitely going to be something to develop as a skill. Oh, GPG failed to sign the data. Why did GPG fail to sign the data? I set up a GPG key before I got started. All right, I'll deal with that later. Fine. I do want to do verified pushes for this, but for now it's fine. Okay. Now, the next thing I want to do, again, has absolutely nothing to do with well, it's not going to be code. What I am doing, however, is doing a little bit of storyboarding. If we can launch this application. Great. Canvas. Dark checkerboard. Appearance. Classic symbolic. I'll take it. Save. Thank you, Inkscape. And we'll do a screen, desktop 1080. Phenomenal. If you're not familiar with Inkscape, it is an open source vector graphics program. So think Adobe Illustrator, but for no money. It's been around for a long time, and I quite like it. So I've just taken this screenshot, and we're going to put it on our canvas here. Let's make the X 0 and the Y 0, just so that it's centered on our 1080p canvas here. And we're going to save this, actually. I cannot save it in projects for right now. So I will save it. I'll save it in my documents. And then we'll move it over when we're done. So why am I doing this? I'm doing this because I want to start thinking about how my application is going to get designed. All right, let's see. Where are my layers? Thank you. Wild. Okay, so we're going to add all this to the background. We'll add a new layer on top. Call this the layout. Hey, OreoBite. Good to see you. So if I'm imagining a full screen terminal user interface, and that's the other thing, we're going to do this as a terminal user interface using the TUI RS library. What are the things that we need to display? So we need to display a list of targets. We need to display probably a menu bar of some sort. So we kind of know that one going in. And we'll do this in Dracula colors, which we'll sort out in a second. But okay, so we need a fill here. Where's my colors? Thank you. So we'll start it like that, and then we'll change it up because that fill's going to be a little bit nuts. Actually, let me black out the top part of this first so that it's not in our way. And I'll just, you know what? Let me get an eyedropper and select that color and then use that to, there we go. Nice and clean. And then we will lock that layer and we'll come to layout. So now we'll make a menu bar here. That's gigantic. That's offensively bright. But we get the basic idea that this would be a menu bar of some sort. Yeah, OreoBite, it's good. We're designing an application here. So this will be our menu bar, and we can add some text to this if we want. Like, File, menu, options, whatever it is, right? Let's bring that font size up and make the color. Wow, I can't type at all, apparently. But you know what? That's okay. Something like that. All right, so we've got this going on. Now what are we going to need? We're going to need a list of targets. And we'll just make some nice, I don't know, thinking like I don't know why it's being like that. Because that's to select the fill. All right. So we'll just make a, actually, you know what? Can we do this with a line? Rather than a, yeah, we can. Yeah, we can. But actually, a box is going to be good for this. But in this case, it's going to be a stroke, not a fill. Something like this, I'm thinking. I'm basically imagining sort of a 3-column situation. So the fill is going to not exist, but the stroke has to be something. So we'll choose sort of one of these nice light colors. And stroke style is going to be, we'll make it 3. Get rid of that fill so it's not so annoying. I promise we will do code at some point soon. But I just want to kind of give us an idea of where we're going. Right, so this would be a list of targets in here. And then the next box, we move these over, will be the interaction. And this will be fairly sizable. This will take up most of our center column, I think. That's looking good. So we're, you know, thinking almost like 2/3 to 3/4 of the view. And then if we go back to, if we think about our notes, what else do we need to do? Pull for data, select interact with targets, display statuses, send data. So perhaps our third window over here could be configs. We may not need it. Maybe we can just do a 1/3, 2/3, right? List of targets, interaction. That may be the way to go. Maybe just keep it simple for right now. Don't hate that idea. But I kind of like the idea of having this extra space for additional information that we need. And then down here for like debug logs. So let's actually do that. Let's put in the debug log. Oops. Let's move this box down here. Twitch chat can go on the right. Actually, Sar, you're not wrong. If this were a proper team server, there would be some sort of chat capability, but this is more like a client to the lots, right? Although we could imagine a way to embed chat. But honestly, everybody's got Slack or Discord or something. All right, I'm not hating this. We got a menu bar up top, which is always like, it's always the most annoying one of these to do. I have no idea what the menu bar is going to require other than file and exit. And probably pop up sort of a popover or a pop-up window for configurations. Right? Key generations, things like that. And of course, you'll be able to launch this thing with command line options as well. So, I have to tell you, for none dollars, I don't hate Inkscape. The one issue I do have with it is how, and this is basically the same issue I have with GIMP, right? Is how different all of the keyboard shortcuts are to Illustrator if you're used to working in the Adobe universe. How does Inkscape compare to Krita? I would say that there's kind of a category error comparing them, Sar. Krita is phenomenal as a painting program, and I would never use Inkscape for that. What Inkscape is good at is vector stuff, right? So I know you can technically do some vector stuff in Krita, but it's really designed for digital painting. That's its primary purpose. Whereas with Inkscape, it's much more for like graphic design, icons, things like that. Because what you're making here is, if I can actually learn how to say config or something. I don't really know what we're doing with that yet, but this is kind of the breakdown of the window. What we're doing is vector graphics, and so what I mean by that is if we... It occurs to me not everybody may know what a vector graphic is and how it is different from a bitmap. So in a vector graphics program like Inkscape or Illustrator, what you see on the screen is determined by instructions to the computer in terms of how to draw it. Now, that doesn't sound that different, but rather than editing like pixels at a position, which is what a bitmap does, what Inkscape is doing is redrawing every time you change the view. So as I zoom in here, look, there is no pixelation in the curve of the circle, right? Because it's redrawing the line for me at every view. That is the difference between a vector and a bitmap. And so when you look at SVGs on the internet, that is why they always look that good, because they're constantly getting redrawn when you change your view. Okay. And that also means that you can export them at any size, which is kind of cool. All right. So we have a basic idea here. We'll start with a 2/3 or a 1/3, 2/3. And they can hide XSS payloads. Yeah, that's super important too. They absolutely can. All right, now that we have this part done, we can start playing a little bit with at least some of the UI stuff, because that's, it'll look fun and it'll be something cool to get started. All right, so we have this done. Now, finally some Rust. In order to make this work, we're going to use the TUIRS library, and there's kind of a lot that goes into using it, but we're going to basically have this stuff imported. This is pretty close to what we're doing. And one thing I do love about the TUIRS library is that it has lots of great examples for how to do things. And so there's going to be a little bit of copy pasta here to get us started. Now, that being said, when we eventually refactor this and clean it up, all of this is going to be abstracted out to modules, because I never like to see my UI code in my... I never like to mix interface code or view code with logic. Despite having done React for so long, which is exactly what React is based upon, I do not like having to do it if I can avoid it. So all of the layout stuff and the UI stuff is going to be abstracted out. We will call functions if we need to, but you're not going to see it in main.rs. That'll just make it more maintainable and easier to read. Okay, so cross-term is sort of what's backing the terminal emulation here. That's what TUI uses. Basically, what TUI is, it's a collection. That's very funny that the popover has the animated GIF from the documentation. TUI is a collection of UI components that we can use, right? Layouts, blocks, borders. But what is doing the drawing on the terminal is cross-term. That's the basic idea here. If we go over to the examples, there are pop-ups. Let's go to like tables. Block border. Yeah. You can kind of see it's verbose. It is verbose. But even to get us started, there are a few things that we want. First of all, we need to change up the main. And rather than using main as a result, or a main normally, it has to be result and then return an IO error this way. Enable raw mode. And then execute is standard out. Enter alternate screen, enable mouse capture. So this is the stuff that actually allows us to work with the terminal in kind of cool ways. I don't know if you've ever used HTOP, but HTOP kind of does this. I don't know if you knew this, but you can click in HTOP. See? I can sort by CPU or whatever. And then I can even click quit, right, with my mouse in the terminal. So modern terminal emulators have the ability to handle this, and that's what we want to take advantage of. And then we're enabling the backend with the cross-term backend with standard out as our buffer. And then we're instantiating a new terminal. That's the other thing that I think is kind of interesting is this UI stuff results in a lot of singletons in terms of object-oriented programming. I know that some of you are doing some learning about object-oriented programming, and classically, one thing that we like to avoid in OO is what's known as a singleton, meaning a class that will only ever have one instance in the runtime of a program. You try to avoid those as much as you can, because if you are doing a bunch of singletons, it suggests that there's a way to do that without object orientation, and you're kind of adding structure where you don't need it. That being said, with user interface stuff, it tends to happen all the time because of the nature of UI stuff. And in particular, yeah, UI programming just comes up with all sorts of anti-patterns. For example, in games and other things with a graphical user interface, there is what's known as the main loop. Even terminal programs would have this, but the infinite loop. It is like the run of the program will run forever until you choose to quit it, right? It's not just a set of instructions that runs until finished. It is the core of the program is a loop that runs forever. And yet you're told as a beginning programmer, don't write infinite loops until you want to. All right, so if you look at what we're doing here, there's a block with borders, and this isn't quite the way that we want to do this. instead, we'll see what this looks like. Because it's sleeping. This is just going to prove that it's working. If we do cargo, I got to full screen the terminal for this, I think. We do cargo run. Compile here. Yeah, see? It actually runs. Oh, so the block actually does kind of what we were saying. And then the borders are, this is defining where the borders are, all four sides. And then what was the block, the area, like what is the size? And it's the size of the whole frame. And this is where we want to start breaking this down a little bit. So if we say targets block, and we give it a title of targets, right now, when this thing runs, I've broken it because I need to change this to targets block. There we go. Now it says targets. So we're on our way, right? We haven't done any colors or anything like that, but we're on our way. Now, if I do let interact block equals block, and then the way that blocks work is that they have, or all these widgets have this builder style, right? So block.default will kick it off, and then the builder model is that we call these methods which will modify the thing, right? Interact dot style. We can do that, but we'll do borders again, which will be borders all, I think. Yes. Now, if we have more than one widget to render, we have to do something about that. And to do that, I think we do have a layout, which we're not using yet, but we should. That's the next section of the docs. How convenient is that? You see how we have two blocks here? And now we're actually creating a layout. And in this case, the direction is vertical. And the constraints are 10, 80, and 10. So let's call that, I don't know why it wouldn't be called layout. Kick that over here. And notice that we're rendering a widget, and we're putting it in the 0th index of our layout, right? So maybe we'll call it something like this takes a frame too. So this is actually refactoring this a little bit. So all of this is inside of terminal.draw, which takes a frame. And so they're saying basically abstract this out into a new function, which I love. So we can do that. Function UI backend, and you can see that we just added backend as a dependency. That's a type constraint, by the way. We don't see too many of those in early Rust. All right, so now Sorry, my shoe's kind of bothering me. Okay, so now we will actually take most of this and pop it in here. And I don't think we're going to need size at this point. But what we will need is something like draw here. I think we just call UI with the frame. Yeah, I think that's right. That's yelling at us right now, but we'll deal with that in just a second. So we'll say so again, we're going to use that builder pattern to create a layout of default. The direction is nope. Direction is, which I have not imported, so I need layout. Oh no, I have direction vertical. There we go. And we'll set a margin of 1, although I might want more of a margin because the margins feel good. And then constraints. So constraints is a slice of constraints, which we don't have. Yes, we do. Constraint percentage. So we were saying that our first constraint was going to be, say, 80-20 for now. So it's 20% on the targets, and then 80% on the interact. And then just fixing my alignment here as a reference, because we're not moving it, we're just getting the reference to it. Dot split. Which we give the frame.size, which is kind of cool. And that's it. Now, the frame, cannot find type frame in the scope. Ah, because we have not imported it, but we definitely need it. Right. And so instead of rendering the widget with size, we're sending it the UI layout. And notice that render widget is called more than once. The first time it's called, it's for our first block, the targets block. And then the second time it's called, so we kind of define out we define the widget, and then we render the widget. And where do we render it? So the first one is targets, so that goes to the first index, or the 0th index. And then the second goes to index 1. And this should be the interact block. I'm not getting any more errors, which is encouraging. And so if we look at how this is done, so now terminal draw just hits this UI function. And so let's give this a go. Interesting. So it should be a vertical layout. That makes more sense. I was expecting it to be, you know, like this. So we'll change the direction to horizontal. And that didn't take too long to be... productive. Now, that's pretty simplistic, all things considered. But it's a start. Now, in terms of interaction, there's a lot more to do. But at this point, we understand we have kind of the theory down for the UI. And now we can start thinking a little bit about the code. Does this support mouse interaction at all? Yes, it does. In fact, there was part of the code that enables it. There is, when we execute, which is basically how to send commands to the terminal, one of them is with the enable mouse capture. So we can click onto different components and do evented programming. That is a little bit more advanced, but it's definitely available. So if we go to our widgets, let's go to like block, right? Base widget to be used with all upper level ones. Yeah. So if we go to, let's see. Let's go to a paragraph. Actually, you know what? Let's go to some examples. Let's see. User input.rs. Seems important. So what are we pulling in? We're pulling in normal stuff, backend cross term, constraint, direction, layout, color, modifier, style. So this is where we actually get to make things look pretty. And then text. Spans and text. And then widgets, block borders, list, which we haven't done, list item, and paragraph. So actually, if we wanted to do a list of targets, we can do that right now, as a matter of fact, which might be kind of cool to see. So there's this list.rs that kind of breaks this down. So we're going to need list, list item, and list state, probably. And those are, those are widgets. So list, list item, list state. And text, spans, and styles. I think I want both of these for reasons. Even if we end up not using it. Let's get them in here and then we can play. So the idea here is, as I understand what's about to happen, we're going to have to render the list items, right? And we're going to have to render them into the block, right? So we make a list, we put it in the block, we put the list items, put them in the list. All of that has to get rendered. And also note that the way that this is done is they create this struct called a stateful list. And that's going to be a thing that we have to do right away. So as a matter of fact, again, to keep this nice and clean, we'll leave it in there now. But it's plain that we're going to have to start moving some of this code out, or it's going to get real messy real fast. Right, so we're going to do struct target list of type T. I don't know why we're using a generic here, to be honest with you. Oh, because it's items of vect. I don't think we need that. Because for now, we'll do state, list state, and items. We'll just do a vec of strings. Just for now, right? So it's not totally wild. But then we do have to define... Oh, actually, we don't have to define list state because list state is defined for us here. We might want to check out what that is, though. Let's read some documentation. So if we go to widgets and list. Nope. Hold, please. Where's that coming from? It is coming from widgets. What up? Oh, it's a struct. There we go. List state. It has two impulse, selected and select. Right? Those are the things that make it a list state, which is fine. And presumably, the clicking events are handled in there for selected and not selected, right? So that might be kind of cool to see. Okay. Let's say targets equals Murphy. Thank you so much for the Prime subscription. Appreciate that. I'm not trying to be too fancy with this. I'm literally just... What's your problem? Oh, does this have to be... This has to be inside of our UI, doesn't it? It doesn't like me doing globals. Yeah, those would have to be consts. Okay. It stopped yelling at me about variables outside of a function, so we're good there. And back to the example. Right, so it's implementing a stateful list. And this is, I think, important. Obviously, if it's in here, it's important. Good job. Impl stateful list. List, yeah. And we'll put in a type constraint with the string. Although I don't know that matters so much. But we do have to, so we have to implement this function with items. Now, could I be doing this with a generic? Yes, but I don't need it to be a generic, and that saves me a little bit of performance if I don't do generics, and saves me some code space as well. But you can see why we would do it with generics here, because this is how we produce stateful lists of any kind of thing, not just lists of strings, but lists of whatever, right? So right now I can do strings, but if I made a list of what will become essentially target structs, right? Targets have a name, they have an ID or whatever, they're going to have this as well. So instead of just implementing it for strings, which is fairly limiting, I would implement it somewhat more generically, right? And then we just create a stateful list. And then the state is going to be the list state default. And then we give it the items. This might seem like a lot of boilerplate, and it is, but I actually really like this part of Rust because this is the kind of thing that helps you reason about your code by being explicit about what your types can do. We're doing this just for the UI component now, but when we start moving over to the channel code and how we think about how channels work, this is really going to help us out. I have to say, working carefully with a type system is... This might be a little bit of a spicy take, but working carefully with a type system obviates the need for a lot of tests, a lot of basic tests, because you're already preventing, especially in Rust, you're preventing things like undefined errors or the kinds of gotchas that you might find in JavaScript or Python or something else that is a little bit more flexible and will let you get away with functions returning the wrong thing or something like that. Okay. And notice that a stateful list also has some iterator components, right? There's next and previous, which is kind of cool. So this allows us to cycle through them. And I'm not going to lie. I'm just going to grab these and we'll take a look at what they do. Right? So next basically is, this is the cycler. If we're at the bottom of the list, it brings us back up to the top. Otherwise, it increments the iterator, and then it selects whatever that value is in the list. Same thing with previous, and then unselect, right? Now, because we have made an app with state, find state, we'll list in this scope. No. Hold on. Oh, I forgot to make the struct stateful list. That's the problem there. I implemented stuff without defining it. Oh, hold on. I'm being goofy. Of course I did. We're actually implementing for target list. There we go. And then, yeah, it's not vec t, it's vec string. There we go. So this is a pattern that if you're learning Rust, you want to get comfortable with, where you define a struct and then you use impl or implement to define the methods that make it up. So with items is kind of, we don't have a raw creator or a raw constructor or a new for this kind of list because we need to start with something. Okay. Ah, perfect. So now we have this app, right, that has items and events. And also notice that we have this lifetime. We have a manually defined lifetime, which we haven't done a lot of in Rust that we've done on this stream. One of the things about Rust that differentiates it from other languages is that it doesn't have what's known as a garbage collector. There's no subroutine that is looking for memory that can be freed and freeing it. There's nothing going on like that. Instead, the way that it enforces memory safety is ensuring a couple things. There's something called the borrow checker, which makes sure that items in memory are not moved from one scope to another, thereby making it impossible to decide how long memory needs to live. Does that make sense? So that's really what the borrow checker is all about. It's deciding how long things need to live in memory. If I have a piece of data and I pass it from function to function to function, like literally that piece of data, not a reference to it, but I pass that piece of data from function to function to function, okay? It then becomes impossible for the compiler to say when it would have to clean that piece of memory up. So Rust puts down a rule saying you can move an item from one scope to another one time. And after that, you no longer have the ability to move that thing. Even if it's something, even if you have a string and you use it in some sort of function, and that function would represent a move of that data, if you're not sending a reference to that string, which is what you should be doing, then that string is moved and you're done with it. You can no longer move it, right? You can't send it to another function. That's it. That's where the borrow checker becomes very frustrating for new Rust programmers, new Rust agents. But at the end of the day, it makes your code a lot more memory safe. So that's one part of it. That's one way in which it enforces that objects in memory do not have to live longer than they need to. The other is this idea of lifetimes. So every item in your code has kind of an implicit lifetime that is defined by the scope in which it exists. But sometimes you need to define a lifetime for some object in code that isn't as clear as the scope in which it's initialized, okay? And for that, Rust has the syntax of defining lifetimes like so. Now, by default, like the first defined lifetime is this kind of quote A, right? We could make other named lifetimes, but by convention, this is the first one that we name. And so what we're saying is we're creating a struct that will have this named lifetime. And then we're implementing methods for this struct with that same lifetime. So we're manually annotating its lifetime. I assume that's because of the way in which we use it and how long we need it to live, which presumably is for the entire program, right? That is the trick with lifetimes. And it can be a little confusing the first time you run up against one of these problems. But let's play with this a little bit and see how it goes. So we have our list, we have a target list. Now we have our struct app. And again, we're using this type constraint, or in this case, a lifetime constraint of A. And we're going to say it has this lifetime here. If this seems crazy verbose, it is. Oh, no. There we go. That's what I want. I want to define the struct first. And then, so the items are going to be a stateful, or sorry, a target list with, again, two things. One, a string reference with lifetime A. And again, we have to define that because without it, the string reference wouldn't live long enough. And then the usize. Now, I think the reason why usize we don't need a lifetime for it is because integers are basically primitive enough that they have like an infinite lifetime. Like, don't quote me on that. Or we literally just don't need it to live that long. And events, which are string references and another kind of string reference. So that's the shape of events, I guess. Okay. So that's the struct for the app. So items that live inside of it and events. Now, in this case, we're just talking about the targets. That's not at all everything that we need. So we're going to rename this to targets for now. But our app would likely have to consume more of the state than that. And in fact, there may be smaller apps that we have to build, depending on what the design is. So now we're going to implement with lifetime of A for the app, also lifetime of A. And yeah, that syntax is really verbose, and it's one of the things that I like least about the Rust syntax is lifetimes, where you have to define it in both the implementation notation and the app, which we've defined up here. All right, function new creates an app of lifetime A, and we're just going to say return app, and the items are going to be a target list with items, right? And where are my... Let's just go grab this back here. I don't even have to define targets like this. Oh, why doesn't it like that? It should. Oh, because they need names. Oh, right, because this is wrong. Right. Our type definition is wrong. They said string reference, but actually, it should be string. And can I get away without the lifetime here? Oh, it hates that. No such field. Oh, because it's targets, right? Missing field events, which we knew. That's fine. Events. So this part, right, we haven't defined events before. I'm going to leave this off, actually, because we're not doing events yet. This is their demo. Parameters. Oh, yeah, we don't need a lifetime A. Let's try it without it and see if we can get rid of it. Because if you can do things without a manually declared lifetime, you should. Let's see. We'll see when that becomes an issue for us. All right. We're not going to do any ticks or anything like that. And here's our app. So this is kind of a different situation. Okay, so here's their UI, and this is really what we want to figure out here. So their UI has an the frame and the app, which is a mutable app struct, just like we built, which is fine. And then they're creating a UI layout, just like so. And then create their constraints, very, basically exactly as we did. Now, the app is getting passed in, so let's figure out where this happens. It's weird. The ordering of this is a little bit not the way that I would do it. Because main is not the last function here. That's a terrible idea. That's really messed up. I don't know why they're doing it that way. Okay. So they have terminal, and then, yeah. So we're going to do it this way. Rather than doing this sleep, right? Well, we'll kind of let that happen for now. Restore terminal. Oh, no, this is still good. So, terminal.draw. Terminal, tick rate. Okay, so the next thing we need is the app. Let app equals app new, which we did. And then they have this run app, which we don't have. And that's kind of what's running the app. But in our case, if we look at run app, what does it do? It takes a terminal, it takes an app, it takes a tick rate, which we're not doing, and then it returns an IO result. So basically, we do terminal.draw. And then there's a timeout here. Now, this part is where we're actually doing interaction with the keyboard. We'll leave this off just for the moment, because I want to see if this thing actually runs. So terminal.draw, this should be good. And we're sending UI, F, and the frame, and the app as immutable. And then in our UI function, which is now taking the app, let items is... Ah, I see. So what we're doing here is once we create the layout, we'll say let items spec list item. Ah, so this is where list item comes in. This is a view component. And I would actually be more explicit with that. I would say list items equals app, and what we're doing is we're pulling the app's items. Well, we don't seem to have the app here. Not borrow. Oh, here we go. Cannot. Did I mess that up? I think I messed that up. In main. No, that's wild. So it's not declared as a mute. Gonna borrow app is mutable. It is not declared as mutable. So if we do let mute app, does that solve that? That's funny. Is there a bug in this code? Does it know about app now? No, it still does. It sees it as an app though. but that's from here. Dot items. Now, an app's items are... Oh, because it doesn't have an items. I renamed it, right? Targets. There we go. Dot items. That's closer. And also, then we don't have this double named items thing. That's just not good style. And we're turning that into an iterator. And then we're going to map over it to do some kind of UI tomfoolery. And then we'll collect it into our vec. So what are we doing for each one of these? Let's say spans from I.0. We're mapping over the item. Okay. So this is the number of lines it takes, basically. So this is a way of translating text into terminal columns. Let mute lines equals vec. Okay, I like this. Spans from... This is so much more verbose than doing it in Python, but that's okay. We're learning how to do it in Rust. Let mute. Let's do let mute. And then for underscore in. Do you see why I don't love UI programming? Oh, this is wrong too. Oh, fascinating. So they're banking on our items being a tuple, but our items are not. So we have to modify this code just a little bit. Right? So let's take a look at what spans are and then understand exactly what we're doing. So we'll go... Where's that? Spans. A string composed of clusters of graphemes, each with their own style. Right. So... if we look at how we're using it here... spans from, and so we're giving it the string. So not I.0, but I, because this is the item itself. Interesting. So now, what is it doing here? For blank in 0 to I.1. Now, I.1 is... for whatever reason, some random integer that has nothing to do with its length. So what are we doing with this? Lines.push, span. So, oh. No, we don't have to do that. That's very funny. So this is like the lines in the list, but we don't actually need that. We just need the item. Lines spans from. Push. Oh, right. Okay, so we're starting with the title and then we're adding things down. No. We don't have to do any of this for what we're doing. So instead, yeah, we don't need this. We just need a list item Oh. Yeah, that's way easier. So what we're going to do is we're going to make a list item by just returning a list item from I. Because we just need the title. We just need the name of the thing. That's it. We can add a couple more targets to make it look more fun. And let's say iMac. I worked hard to get that Mac OS implementation working. From not capital. List item from I dot style, or I guess list item new, right? Looks like new. And then style which will start with style default, and then we can build that as well. Yes, we can. Dot FG. So the foreground is going to be color magenta, and then dot BG is going to be a color dark gray. Yeah. All right, we're getting somewhere. That's the style. Yes. And it doesn't like I, because I is the trait-bound text from it's not satisfied from... Oh, can we just reference it? Nope, hates that. Wait, hold on. I.asref, does it... We'll take that. Sure will. Okay. Rust. Okay. Basically what happened there was the borrow checker was getting us. So basically we had a string, right? And we couldn't move it into the list item new function. It was saying, you can't do this. You cannot move it. It didn't have an implementation because the borrow checker wasn't going to let it happen anyway. So instead of giving it the string, we gave it a reference to the string. And now the list item will render, I hope, appropriately. Why do we have two different variables named items? That's wild to me. Oh, they're shadowing the variable. That's such a weird thing to do. I would never do that. I like this library, but I gotta tell you, some of the choices they're making in this example code are alarming. So just to clarify what's happening here, on line 213, they declare a variable called items, which we've been just working with. Now we called ours list items. But then they create a new variable on line 230 that is the exact same thing. I mean, it's not, but it has the same name. And I don't know why you would do that. Now, what is this? This is another list. Right, this is the actual UI component. So we could call this like list view. Might be how I would describe it. From our list items. See that? And then it has to be contained inside of a block. Block defaults. Borders. All? Sure. Title. Targets. And then I like this dot highlight style. This is kind of cool. And again, you can kind of see how this works, where we start with style, default, and then we add to it .bg color light green. This is going to be atrocious to look at, but that's fine. And dot add modifier. Did I not? Bold. Yeah, I like that idea. Okay. And dot highlight symbol. Just to see if we can. Actually, that's very funny. We're doing that. Okay. So this kind of takes the place of our targets block here, as I understand it. Right? So instead, we're going to render stateful widget. And so the widget here is going to be our list view. And then the area is still going to be our layout, which we defined, the UI layout. 0. And then the state has to be mutable. Mute app.targets.state. And toss a semicolon on there. And unbelievably, this might actually run. Okay, it did for a second, but the reason why it died was because I don't have an infinite loop, basically. So I'm gonna re-enable this thread situation. Or this won't allow interaction, I don't think, if we do it this way. Yeah, because I can't click on anything. But we did create a thing. And then, yeah, all of the events from the mouse show up in there. That's very funny. So our targets showed up correctly. That's kind of cool. Now, in terms of the actual interaction with this thing, which we want to have happen, I need this infinite loop, right? Which is this run app. But I can do this in the main that I have right here, right? Because you can kind of see how that's put together. So rather than having run app, I can do a loop. And here's our infinite loop. And then, yeah, the terminal.draw is the exact same. And Now, if we want to actually interact with this thing, we need to deal with time. So essentially, we're polling for events every whatever the tick rate is. And so where is the tick rate defined in this one? Nope. Come on. Run app is called from main, presumably. Yes, tick rate, duration from millis. So every every quarter of a second, basically. So I like this. We'll go grab this. And we have duration imported. Duration is it's a core thing from time. It's part of Rust. Right, so inside of our loop, we're doing the terminal.draw, but then we're saying let timeout, y is caps lock on, let timeout, cool, tick rate dot checked sub. And we need this last tick, which is kind of cool. We need instant, I think. So we pulled in duration, but I don't know if we pulled in instant. Time duration. Time instant, yeah. All of this for a simple 2-column app. Let's tick down the last. Unwrap or else. What are we unwrapping or else? Duration from seconds. Interesting. Okay, so what is all of this code saying? We're defining a timeout, which is how long to wait until our next. So we're checking. Checked sub. Checked duration subtraction. So we're checking the difference between the time since the last tick and now. And if there's an error for whatever reason, we just return 0. And if cross term event poll timeout, then we are checking for key codes. So every time it pulls the UI, we're looking for key codes. If let event mouse would be interesting. But let's just do, actually, yeah, event key. We'll do keyboard stuff first. Equals event read with an implicit unwrap there. Not something that I love, but I think it'll work okay. So they're using a match statement here, where key code character Q will be for quit, which doesn't suck. This just ends the application, and then left unselects. Down is next, up is previous. I actually don't want left to be select. I want key code. How is it? Where is spacebar? Maybe it's a car. Maybe it's a car, like so. Oh, so many things just went wrong. Why? If let event key. Oh, I need the key. There we go. And then it's app.target. Targets, I should say. There we go. All right, let's see what this looks like. That is cool. Right, so if I press down, I get this highlighted up, and then spacebar. It's selected by default, but if I press spacebar, it deselects it. Oh, man. That is kind of awesome. And then Q will quit out. Okay, that was a lot of effort, but I'm pretty happy with that. It's the little things, you know? Now, I do want to modify my list view here, or my list item. Because dot. Can I have like a... They don't have a margin. Basically what I want to do is I want to add some separation between my items there, which I would do with margin somewhere. So let's take a look at the documentation. These kinds of modes for what keep me coding. Oh, they're the best. Absolutely, Neon. That's what it's all about, is the magic of making something work, right? You work for so long, and then when it actually pays off, absolutely. It is what it is all about. Well, that and, you know, building something useful for other people. But who cares about them right now? I made a thing. Right, so we want to look at TUI. Where's my widget? Borders. Borders all. And then that's gotta be, all right, so it's gotta be a style situation, right? So widgets, style. There we go. Style. G. You don't want modifiers. What? This background, foreground. And there's an add modifier, but then we need modifiers. Let's look at our modifiers. Slow blink. Cool. So the block has borders, but the list item does not. Yeah. Unless I can do it first. No. I guess I can put it inside of another block, but that's small potatoes. Let's run it again. Interesting. That's not what I wanted to have happen. Oh, also, look at what's happening now. By just moving my mouse, right? It has not fixed my mouse problem. Why is that happening? That's got to be happening because... Oh, right, because it's not ending the... All of this should happen on quit. We never get to this code. That's why. So instead... Please, God, fix my terminal. Okay, it didn't show my cursor. Okay. This is working still. Quit. Why is it clearing the buffer? Yeah, I do not know. Oh, because it's not dying. Oh, I forgot to... I forgot a line. It doesn't return. Let's try that one more time. And my mouse is fixed. Okay, great. That's good. That's good. 10x Developer asks, what is a team server? And that's a great question. So we talked a little bit about it at the beginning of the stream. So a team server is an offensive security concept where, let's say that I have put an implant onto a target. Maybe it's Meterpreter, maybe it's Cobalt Strike. Cobalt Strike or Sliver or Havoc or Offensive Notion. And now those implants are going to have to phone home to something. Now, if it's just me, then it could be a simple listener, right? A simple listener. But if it is multiple people on a team that have to interact with multiple targets during an engagement, then what you want to use is something called a team server, where multiple people can connect with their clients to a single server and interact all together with the targets that are phoning home to that server. That's kind of what we're talking about here. So the idea in this case is it's a little bit of a misnomer because we're really building a client, and the server in our case is trusted sites, whether it is Notion, whether it is GitHub or whatever else. So the trick here is that we are using these trusted sites as our communications channel for our implants on our targets. If it would be helpful to folks here, if you're new to the stream, I will happily demo Offensive Notion to give you an idea of what I'm talking about and why we're kind of building the next level out. That's cool. All right, I will do that, Super Axe Hacker. So, to make that happen, let me go over to my Offensive Notion page here. And hopefully I haven't broken anything in my dev channels. We'll see how this goes. And let me get my handy-dandy Notion client open, and we'll go to my C2 test page. So the way that Offensive Notion is designed to work is you configure the implant with things like the parent page in Notion, the note-taking app to work with, and the API key, basically, that you have to interact with Notion via the API. And then the agent will execute in that way, communicating and sending data to a child page that it creates, and then listening for new commands. So let me show you what I mean. Let me fire up this test agent here. We'll do cargo run. To recompile because I updated a bunch of stuff. But as soon as this starts running, now this will run in the Linux context in WSL, but you'll still get the idea. Boy, had to recompile everything. Awesome, it launched. Okay, so we're starting. All of our configs fire up. And if we now look at Notion, we see down at the bottom here, we have a new agent that phoned home. Now, if I want to interact with it, this is how we set it up for Notion. We can do a to-do, and we'll do a who am I, and then we tell it that the command is ready to execute with a target. And this thing is going to poll every 10 seconds or so. And then what it does is it executes the command locally on the system, right? And then it returns the data. And none of this, by the way, nothing that I've done so far runs shell commands. This is all done using OS level APIs so that we don't ever have to make that kind of obvious execution. But if we wanted to, we could. There is a shell command. So if we do shell calc.exe, even from WSL, this will work. This will pop a calculator. See? So that's how Offensive Notion works. Let's shut it down with the shutdown command. And in the actual deployment of this, we actually designed this to look like Notion so that when it fires up, it actually launches a fake Notion app. Oh, whoa. I guess some folks have not seen this before. It's been kind of old news for us for a while, but yeah, if you want to check it out, you can go see it at Offensive Notion. Quick plug for it, I guess. Yeah, it works really well. And as a matter of fact, as I said, we even went to the trouble of writing a build for it so that it compiles with this red Notion icon in the Windows XE. So when you run it, it looks like Notion. And in fact, if you have the default config set, it will even launch Edge on Windows in app mode to make it look like Notion has in fact launched, even though it is phoning home as malware. There's a full wiki as well to explain how to use the agent. Full agent interaction, explaining all the commands we have. We have, this is a little bit funny, we have uploading is something that the Notion API cannot do. And so we have AZ upload and S3 upload, where you can actually send stuff to storage containers or S3 buckets that you've configured for yourself. We have download, though. We can put stuff on the box. If you have the ability to elevate privileges one way or another, you can do that. We can determine what privileges you do have. Once you do have admin on Windows, there's a get system, so you can elevate to system. We have shellcode injection. We have persistence a bunch of different ways. And I'll mention, since this is something we worked hard on, the agent works for Windows, Linux, and Mac OS, and persistence works across all three. Does Notion not allow you to upload images? So Notion doesn't allow you to upload anything, technically. And this is a little bit of a hack on Notion's part. Let me remove this agent here. So basically, when I upload an image, like this awesome picture of the I was about to say the Nakatomi Tower, which it is, but actually it's the Fox Tower in Century City. When you upload anything to a Notion page, what's happening in the background is Notion is using its own S3 credentials to send that to an S3 bucket, and then what you get is a link, basically, to that S3 asset. So the Notion API never uploads anything. It just uses AWS. So we can't use it to exfiltrate data directly off of a target, which is why we put in the S3 upload and AZ upload commands. So you can use Azure or AWS storage to do the same thing. We even have a couple things. We have self-destruct, which will delete the agent off the system. But yeah, persistence. We have persistence on Linux through systemd. We have it through bash rc. We have it on Windows through scheduled tasks, through WMI, and through startup programs. I feel like there's another one. Yeah. So my bad. Linux, we have cron, bash rc, and systemd services. Windows, we have startup registry, WMI, and scheduled tasks. And then on Mac OS, you persist via login items or launch agents. Yeah, so here's the thing. We accidentally basically wrote a full C2. And now we would like to move it out of just Notion. And to do that, we have to abstract out the way that the communications actually happen and make these work in a more general way. Because there are tons of other trusted sites that we might want to use, like Slack or Discord or Twitter. All of these different ways in which you can use trusted sites as your communication channel, right? It doesn't just have to be Notion. As long as we can normalize the way that content is being transferred back and forth between whatever that channel is, then we could essentially write an interface for anything. Virus total comments, that's a really good one. Yeah, definitely. As long as there's a way to interact with it programmatically, we can write an interface to make it happen. And if it's happening over HTTPS, then you have that level of encryption. And then the next step that we're trying to go for is to have RSA encryption, basically asymmetric encryption, so that the agent is sending messages back to the server that are encrypted with our new client's private key that the target never sees. So it's kind of like a one-way encryption situation, which means defenders will never be able to see both sides of the conversation. Okay, so that's just everything. So you're trying to make it so you can select from multiple trusted apps. Yeah, exactly right. So what you would do is you would configure your agent to work with a specific channel, whether that channel is Notion, GitHub, VirusTotal, Discord. The goal is to develop some kind of protocol that you can then relay. I wouldn't call it a protocol, SAR. I would basically call it an interface in sort of the programmatic term. Basically what we're going to do, I'll give you an example, actually, from Offensive Notion. Did I close Offensive Notion? Give you an example. So one of the things we did in the architecture of Offensive Notion was we wanted to make all of the commands really, really easy to add to. So the way that our commands work is first we use Rust's enum capability, and we just describe all of the commands here, right? These are all the commands that we have. And so the first thing that you would do if you wanted to add a new command to Offensive Notion is add one here. Then the next thing that you would do is add it to our parser for command types, right? Because what this is doing is it's pulling down the string from the channel and figuring out what it's asking for. After that, this is where the actual stuff happens. And you can see that we're calling into each command's module, and we're calling its handle function. So the idea is that all of the commands have the same basic function signature. They have there's a handle function inside of the module, and the handle function can take the arguments, optionally the config options that it needs, and then the logger if there's logging that needs to be done. And uniformly, all of them return string data. That's it. And so regardless of what the command does internally, the output is string data. And so when we go to our main.rs, that is what we right now, excuse me, that is what we're getting, right? This is everything. So whatever the Notion command is, we call its handle function, and then we just wait for it to happen. And then, and we do a lot of work right here to make sure this never fails. And then, this is the stuff that we have to abstract out, by the way, right? This is kind of like the Notion-y stuff that we have to abstract out into its own layer. But then we complete the command where we check that box, and we send the result. I think this is going to be a Notion-specific thing once we're done. But then we send the result. So regardless of what the command is, the same thing happens. Handle, and then finish. And then we do a final check to see if the command was shut down or self-destruct, in which case we shut down the agent. That's it, right? So when I talk about generalizing things out like that, I would say that's kind of what where I want to go next. We want to create a definition or a spec, right, for any kind of channel that we can use for that communication. So let's do a little bit of that. If we, yeah, let's make a new module folder here. There is one other trick I forgot to mention that we use in Offensive Notion, which is that we encrypt. Why do I keep closing this? We encrypt all of the basic string data with litcrypt, which means that all of the strings in our messages, like this logout macro, is actually encrypted at compile time. So all of these easy wins for defenders are encrypted with a random key of our choosing when you compile. So it's actually much harder to build string-based detections against Offensive Notion because all of this stuff, there's the litcrypt macro, all of this stuff is encrypted. In fact, Defender had a working detection for a while for Offensive Notion. And do you know why? Their sample that they got was based on our test encryption key, which was Offensive Notion. The second we changed the encryption key and ran new samples, it was no longer getting detected by Defender. And there's other stuff that we can do. We're not doing yet, like API unhooking or all that wild stuff. But yeah, so next step is to kind of unofficially, in my head, it's like the evolution of Offensive Notion to a project that I'm calling Offensive Trust, which would be kind of the new version of the same tool. But Offensive Trust would have kind of two parts. Offensive Trust would be the agent, and then Trusty Team would be the way that you can connect to any one of these channels from a single unified interface. Kind of wild they don't detect LitCrypt. What use does it have besides obfuscation? Yes, obfuscation can be legitimate, but still. So here's the thing about LitCrypt. It's not... LitCrypt never makes it as a detectable thing into the final project. Because, especially when you strip symbols. Because LitCrypt is not... I mean, it's kind of a library, but really what it is a macro. It's a procedural macro that rewrites your code at compile time to do the encryption. So literally, it's so wild how it works. Every time I call LitCrypt, I actually have a couple of macros in here that'll give you an idea of what's going on. Donut would love this conversation, by the way. We go to, yeah. So I have two macros that I wrote. Notion out is the easiest one. So this is a simple macro, but it uses LitCrypt. And every time I call Notion out, which, by the way, is no longer called that, it's called channel out, but every time I do this, it is pulling in the statement and creating a new string that begins with the LitCrypt encrypted string. And then, right, we add to it. Now, the base string is encrypted here, and what isn't in this particular version of the macro is dynamic data. So it's not something you can know at compile time. How long did this take you to dev? Husky and I started working on this in January of 2022, and it was usable by March. And then we've been tinkering with it ever since. I think that's right. When was the first release? Oh, my bad. Actually, the end of February was our 1.0. And yeah, we've been working on it ever since. 1.1 was the macOS build. And April, yeah. It's an actively maintained project. Okay, so let's think a little bit about this here. So I'm gonna make dir channels and touch channels mod.rs. Oops, I want to mv channels to source. There we go. Okay. So if you look at how modules work in Rust, right, you can kind of see it here if we go to source and we have the command module. But there's this mod.rs, which is actually kind of the core. And then from there, we're actually importing the other command modules into it. And those structures are literally just the function in most cases. But we use the mod to define anything that we need to define and be kind of like the core of the import when we go to import it. So it would be in the mod.rs inside of channels that we would define things. So in this case, if we were to find like pub struct channel, we'll call it like name string, just to give you an idea of how this works, right? And now inside of main, what I can do is I can use I think. What am I getting wrong? Oh, I have to say mod first. I have to find mod. Mod channels. There we go. And then I can say use channels. And then there's the channel struct available to me inside of main.rs. So that's how imports work. But what is a channel, really? So one of the things we know it has to have is a config. So we're also going to describe an enum channel config. And this is going to be a little bit strange. Yeah. So there would be Notion config as one of them. And just for a second one, let's call it Discord config. Right? And so it's an enum because it's variants of sort of the same idea. Now, the configs have to contain something, right? It can't just be this variant. It has to contain data. But we'll get there in a second. But importantly, it's a channel config. Those are the things that a channel has. A name, and then a config, and do I want it to be... I actually don't know if I want it to be a struct, now that I think about it. I think I want it to be a trait. Which might seem a little bit strange. What is a trait? But it is, in fact, this. It's defining shared behavior. So a trait defines functionality a particular way, or a particular type has can share with other types. We use traits to define shared behavior in an abstract way. And that's actually what we want. Right? So I think we might want to do this slightly differently. In fact, let's knock this off. And we'll say pub trait channel. And now we have to define what are the things that make a channel a channel. Neon asks, do Rust traits work kind of like decorators in Python, or is that completely different? Which kind of decorator are you referring to? Well, no, I guess kind of all of them. No, is the short answer. And the reason is that decorators are syntactic sugar that are adding stuff to your code behind the scenes, right? So when you think about adding like a getter or a property decorator or a method decorator or a class method decorator inside of Python, they're adding a whole bunch of code that you're not writing. Traits don't really do that. The best analog in another programming language that I can come up with, there are two. In Haskell, traits and type classes are essentially equivalent. They are, and then in C#, interfaces, and I guess TypeScript, interfaces and traits are the same thing. Traits, consider them like a spec. They are an expectation that types must adhere to in order to be said to implement that trait. So I'm going to define this channel trait. It's going to have a bunch of functions, the methods, and they all have to do this thing. And then when I make a struct like a Notion channel or a Discord channel, or just call them Notion or Discord, they will have to implement those same methods in order to be called a channel. Did that make sense? I really don't know if that was a solid explanation. It's a generalizing of the things we expect. Yeah, I think I thought I said that, but yes, just like interfaces in C# or Java. It might be a protocol. You'll see it more when we do it. So it's going to be actually a pub function, I think. Send. And then we'll call it a Digital Warhead. Thank you so much for the resub. And call this result string, and we'll leave this empty for now because I don't want to figure out exactly what we're doing. So send is going to do result, and I actually don't have to implement it, right? This is not the implementation. This is the definition. And then pub function receive. Which also is going to produce a result and string. For now. Got to stop doing that. Or no, that was right. Semicolon. And semicolon. So send and receive. If we go back to the notes that we wrote, what else does it need to do? We need configs, but those will be part of the struct, basically, as opposed to anything else. But update is going to be something that we need to deal with. So pub function update. And then this is where we need to new channel config. Yes. How do I want to do this? For now, we'll do config options. It's not really what I want to do, but it's the basic idea. So update will take a new config options. Missing type. There we go. And it will return a result as well. And now we have ourselves a channel. Pretty simple, right? It's the implementation that gets funky. But these are the things that make a channel, and these will be the methods that we rely on when we create a channel and we use it to get data. Do you see what I mean about how types allow you to reason in interesting ways about your code? By using the type system, you end up clarifying your thinking. At least I find that to be true. Okay. We don't need the pub for any of these, do we? Well, what's your problem now? Oh, it actually requires this to be an error. Now, there are a couple of ways to do this. The quote-unquote right way is use error, right? And what is error? Error is a trait. And error is a trait representing the basic expectations for error values of types E and result type E. Errors must describe themselves through display and debug traits. Error messages are typically concise, lowercase sentences without trailing punctuation. So we can, in fact, do one of these. Obstruct channel error. And we also want to use some decorators. Derive, debug, and display. And yeah, there's a quick fix for that, which I didn't import, which was use cd. Come on. I always forget where display lives. FMT. There it is. I was like, I knew it was something silly. Now, display is imported here, but it's only a trait without a derived macro. I know. Oh, we have to implement display, which is like so. We have to write a function format. But first we will do like so. Actually, can we get away with a string ref for this? Why not? That'll solve some problems later. And then we'll do impl display for channel error. And then what we do in there is we use this format, right? And then we just say write. And then in this case, it would be self.message. And then we need to import format. Much better. And so then now we can use... Oh, it doesn't like that at all. Okay, so the message does have to be a string. Should have known that was going to be true. But now we can say that the result type is going to be either a string of success or a channel error. See how that stops screaming at us? And it's because we created an error type that satisfies the requirements, and we no longer need to have this imported. Now, that might seem like a lot of work. And, you know, it is. But being explicit about types pays off for you in the long run. Oh, I need to make the trait. That's got to be pub trait channel. There we go. All right. And update is annoying. Why does it not like update? Private type. Oh. There we go. Config options. Okay, now this is how a channel looks mostly. But oh, you know what? I think config options is going to be a trait too, now that I think about it. Which itself will have, for one, an update. Yeah, now it's starting to come together. So we're going to make a function update for the config options that allows it to change itself. And I'm doing like recursive type junk here. I don't know if that's helpful. Because at some point, we need to get down to what the config options are. Let's... Yeah, that's not going to work, is it? Trait objects must include dyn. Yeah, I don't want it to be trait. Just kidding. We're going to go back to a struct for now. And then we'll think a little bit more about that once we implement something specific. So let's add a notion.rs. So now in here, we're going to use create channels channel and channel error and config options, I think. See how we imported that from the top of the module? And then we'll say pub struct Notion channel. And so what are the things that make a Notion channel? Well, this is where some of the config options come in, right? But we'll not add them to the config options right now, just so we can reason about Notion itself, because we're fairly familiar with it. And for this, I am gonna open up code in this window as well, so that we can have something to refer to. God, there's so much going on in this code base. But the good news is that if we go to config, pretty much have what we need. So there's API key parent page, and then insofar as what the Teamserver client needs to know about, we don't really care about the launch app, but we do care about sleep and jitter. But these are actually things that every agent is going to require. So that's a little bit higher level. So I'm going to leave those off for just a second. And environment checks are as well. Environment checks are kind of a cool thing Husky came up with, where you can add in configurations into offensive Notion where if... Let's go to the env check, because it's kind of cool. Basically, we have 3 checks possible right now. We never did domain joined, but username, hostname, and domain. So you can write rules to say if your target doesn't match this specific pattern, or if it does match the specific pattern, then the agent will just die, meaning that you can scope your agent to only run on targets that you wish it to run on. So that was kind of a cool OPSEC thing that Husky put into the agent. Anyway, so in this case, you see how we did the config options here? This is kind of how I want to do this for the... config options. But, okay, so API key, string, and then the parent page, also a string. And then that's kind of it for the Notion channel. The Notion channel is, believe it or not, quite simple because of the way that it works like this. And then basically impl channel for Notion channel. Self, and then the data is a string, and it's going to return a result of a string or a channel error. Unnecessary visibility. I keep doing that. Fine. So, what does send look like? It's actually not that bad. Let's go to Notion. This is it right here. So we know we're going to need request and SerDJSON. And in fact, let me go grab those from this cargo right now, because for sure we're going to need them. It's impossible we won't need Tokyo as well. But we'll leave that off just for now. But I know for sure we'll need Serdi and SerDJSON. Request is the HTTP library. Crazy handy. I really like Rust's HTTP library. All right, so we know that we're going to need these. And actually, you know what? I'm going to be a little bit better of a Rust developer this time and put the scoped dependencies inside my scope, right? The entire module doesn't need requests in CRD-JSON. It's the Notion stuff that does here, the implementations that do. So I can actually put the imports wherever I want. And in this case, I'm going to put them here. Wow, just found that typo. This is a Notion limitation. Yeah, so this is a Notion limitation where... This is the maximum character size of any block in Notion. And it's literally this. I don't think we have to do anything else. Let's take a look at this code. So we'll call it output. Or no, it's not really. It's call it data. But it's the only time we use that term. So what are we doing here? We're basically converting our data, whatever it is, to JSON. And then we're sending it off. Now, here's the trick. The send in this case is going to be a little bit different. This is the basic concept. But not entirely. I'm back. Will the team server be mainly for Notion C2 or its own standalone thing? No, Oreo. So the trick is that if you see the way that we're writing this, we're implementing a channel trait for the Notion channel. But in fact, this is meant to be abstracted out so that we can do this for any trusted site channel that we can imagine. Anything that we can interact with programmatically. If I can hit it with HTTP, basically, it becomes a potential for a channel. We just have to write the implementations for these three functions. Send, receive, and update. Yeah, you can do Discord. You could do GitHub issues. You can do Twitter. You could do anything, again, that has an API that you can configure or that we can access over HTTP in some way. Then we can write an implementation for it. That's the idea. And then the terminal user interface, which I'm still very jazzed about. Look at all the stuff it needs to do now. Yeah, could do Twitch. And then the terminal user interface would allow you to interact with any one of your targets right from here. So regardless of channel, we might indicate what kind of channel it is with something here in our targets list. But then you can just interact with it here and not at all have to worry about what the channel is in the background. You're just using trusted sites, and this handles everything in the background for you. Okay, so the send that we had from the agent, it works sort of the same way, except that chunk size, map, JSON block. Oh, you know what? We won't have to do this because send is always going to be a single thing. right? The difference was that when we were sending output from the agent, it could be gigantic, which is why we had to chunk this up. But we actually don't have to do this for the server, because all the stuff that we're sending from the server is going to be small, right? It's commands that we're sending. Receiving, different thing. But sending, easy. So we're almost like flipping this, really. So in fact, what we want to write is, we've got the JSON object. So basically we're going to do, yeah, actually, something like this. Command, which is going to be a Cerity JSON value, equal JSON. And the way that the JSON macro works is that you give it a JSON object, for real. And you just write the JSON object as you would. So the object is going to be a block, but then the type in this case is going to be a to-do, I believe, which we can confirm by actually looking at the main.rs code for right now. Indeed. And we can also confirm it with the Notion API spec. API reference. Come on. Oh my God. Don't, web developers, don't do that. Do not hide your navigator. That's so annoying. So it's a block object. That's an example. To do. This is what I want. Paragraph, heading 2 blocks, call out blocks, quote blocks, bulleted item, numbered list, to do blocks. This is what we're doing. So see how we do this? So object block, type is to do, and then we give it essentially just text and content, right? Yeah. Janice, thank you so much for the follow. Text. So we're not giving it rich text because we don't have to, basically. And notice that it says text and then a 0, so it is an array. And then inside of that, we give it another object, basically. And the text of which is basic block. Thank you for the follow. Content. And then we do yeah, data. And that's it. That is absolutely it. Think. Let's see if there's anything else that we need. Oh, checked is false. And actually, it's to_do, right? Yes, it's _do. There we go. And then checked is false. So what we're doing with this, right, is we're using the unbelievably OP Serity JSON library to build this out for us and then send the command. I no longer need this. And then the way that we would send the command is we send URL, the URL base blocks, and then I don't even need the command block ID anymore because the command block is the to-do itself, right? So the way that we do this in Notion is that we attach to the checkbox. Let me show you, right? So go to the trash. It's like the last thing that we did. Boy. It's fine. So basically, the way that this works is that the command is a first level child of the page, right? But then what we do for the output is we attach it as a child of the to-do. But we're not doing that right now. What we're doing is we're getting the we're creating the command. So we don't need the block ID in this case. We do, however, need the URL base, which is a thing that we'll need as part of the config. And then we don't need to do the body thing. And then we do end command. And then that's it. If r.status is success, then the result text is .unwrap. And then we can do, if we do the logger, we can do the debug if we want to. We haven't implemented the logger in this though, so we'll leave that off for now. And that is how we do send for this code. Now, receive is going to be a little bit different. Because the receive, we will need to get the command block ID. So that is a little bit different. We'll have to think about how to do that. Because one of the cool things with Notion is that we could do this asynchronously, right? We could actually write as many to-dos out as we wanted, and until we put the target emoji on it, then it would just like, it would not go. But, and then they would happen, if we unchecked a to-do, it would rerun it, actually, which was kind of cool. But doing it through this way, we have a little bit less flexibility there, so we'll have to account for that. But I think this is a good start. You saw how we reason about some of these things inside of Rust. And it's been a fairly long stream. I think we're going to call it a night there. Add some final commits here. So we'll commit and add Serity request. Well, hello, GoPro. 15 months. Thank you so much for the resubscription. send that right up. Yes, unfortunately, we're closing it out. But I will be back on Saturday. I've got some cool stuff planned for Saturday. So I will be streaming at 10 a.m. Pacific then. And let's see if there's anybody on the hack list who is currently streaming. Oh, Anya's streaming. Perfect. We'll send folks her way. If you don't know about the hack list, there are a lot of great and talented InfoSec streamers. You should check them out. And we're going to send you to one right now. But until next time, friends, please be good to yourselves, be good to each other, and happy hacking. We'll see you next time.